Hi all, so welcome back. In this little tutorial, I'm going to show off how you can use this distribution class that we created to model some normally and gammally distributed arrays. So the first thing you're going to notice is I've created a new main file called _main. Now this is a special reserved name in Python. This is going to execute when the package fitting distributions gets run. As you can see, PyCharm recognizes that this line here, if _name equals _main, is a runnable executable. So essentially this is telling PyCharm, and hence any interpreter, if I want to enter and run this application, I just run it starting here. Now the other thing you're going to notice is this _init file. This defines a Python package. As you can see, we are relative path importing our distribution file, and then importing the distribution class from that file. And then here, we are defining the exports of this package. In this case, the only export of this package is distribution. Now the way this works is if I were in some other file outside of this project, and I wanted to import this distribution class, I wouldn't have to say from fitting distributions dot distribution import distribution. I would just say from fitting distributions import distribution, and that's equivalent. So it reduces the amount of code overall that you have to write, and it also organizes cleanly what you want people to be able to see and what you don't. If you hadn't done this and tried to import from just this file, you would actually end up getting this dist names, you'd get SciPy, you'd get SciPy.stats, and you don't necessarily want all those things. You just want this distribution class. So that's what this _init file helps you do. Now, back to the main file. What we're doing here is taking 1,000 samples from a normal distribution with 0 mean and unit variance, and we're just creating a data set for that, and then we're fitting it to an unfitted distribution here, and we're going to plot that against the data set that we had before. And then here, we're going to generate some more random variables from a gamma distribution with a parameter 1, and we're going to fit our data to that. And then we're going to plot the results again. So if you see, let me go ahead and run this. As you can see, this is the results for our normal distribution. Now we can see the difference between the fitted, which is in blue, and as you can see when they overlay you get this orange color, so for the most part we're pretty on the ball in terms of actually modeling what this distribution looks like. And now if we exit out of that, we'll get a new distribution. This is for our gamma random variables. So these are the actual samples that we've taken randomly from a gamma distribution with a parameter 1. And these are, these are our fitted distribution models, and these are our actual samples. So as you can see, it's a little bit off, but the general shape of the distribution is matched very well by our class. So that is indicating to me, at least, that our distribution is good at fitting these data sets, and that it can accurately and reliably predict which ones we should be modeling. Under the hood, what's going on is we can actually see what type of distribution dist is. So if at the end of this we want to print out, we can print dist.distribution name here. We can write a little comment, should be norm. And similarly here, if we print out dist name, dist.distribution name, should be gamma. Now we can try running this again. Fitted distribution to norm. Let's see, we're back here. Now we're going to go back to our execution. Exit out of that. Yep, norm. Fitted distribution to gamma. Should again say gamma. Oh, turns out we fit to a y-bell min. But that's okay. We just don't necessarily have enough samples to accurately compare them. And that also shows off the limitations of this test. If you want to be more rigorous, you could also implement something like a k-fold cross validation for sumness testing. Or you could also use a chi-square test. And I believe in a few videos on, I'll go ahead and implement a chi-square test to show off how that would work in this example. So anyway, thank you for watching. I hope you learned a little something about SciPy and NumPy and how to model random variables using those packages in Python. Ciao.